Hey guys, this is Miss Sauer. I wanted to make this video lesson for when I was going to be out. Today's lesson is going to be 2.3b, which is going to be over volume of 3D figures. So for your warm-up today, I already have it on this video right here to where you can see. Let me blow this up so you can see it better. 1 second. So you were asked to determine the area of the cross-section for each of the figures. So on your warm-up, I have this image right here that shows you that a cross-section is if you just cut it in half, and the cross-section is the 2D image of when you turn those halves outward, and you can see what that cross-section looks like. So for that first one, that cross-section would be a circle. For this one, the second one, the cross-section would be a triangle. It's basically what the base is. For this cross-section, it's a rectangle. So for the first one, and this is warm-up here is for you to check your answers. The cross-section of this first one, and I'm sorry on the paper it didn't copy real dark, but this length is 5, this length is 3, and this height is 4. So the cross-section of this figure, if I cut it in half, is a rectangle. So you were finding the area of that rectangle by taking length times width, so in this case 5 times 3, and we got 15 centimeters squared. For the second one, the cross-section is a triangle, and they mentioned right here that side AB is equal to side AC, and their lengths are 8 centimeters. So and the angle BAC is 30 degrees. So I drew that triangle showing the side lengths and that angle in between, and then using our area formula of 1/2 AB sine of C, we substitute in our measurements. It's 1/2 8 times 8 times sine of 30. And we get 16 centimeters squared for that triangle area. And for the third one, when we do a cross-section of this one, it's a circle with a radius of 4 meters that they tell you here. So our formula for area of a circle is pi r squared, so that's pi times 4 squared, giving me 16 pi, or as a decimal, that would be 50.3 to 3 sig figs. So 50.3 meters squared on that one. So like I said, what we're covering today is volume of 3D figures. So we're going to learn the names of how to find the volume of 3-dimensional figures in order to determine the volume of composite figures. I think I meant to put formulas there, not learn the names, but learn the formulas. So find the volume of a prison. We're going to use the formula area of the cross-section, so like what we figured up on our warm-up, we're going to take that area of the cross-section and then just take it times the height. So in that first one, we had just figured out that area, let me draw that cross-section again. So you just figured out that this area was 5 times 3, so the volume of that is just taking that area's cross-section and taking it times this height of 4. So volume equaled, we got 15 for that area cross-section, and then times the height, which is 4. So 60 centimeters cubed, because we're talking volume now. So area is units squared, volume is units cubed, because it's 3-dimensional. Same figure from our warm-up. We have that triangle cross-section. You found the area of that to be 16 centimeters squared. So the volume of that would be the 16 centimeters squared times this height going that direction. So times 10. So that gives us 160 centimeters cubed. And then just again, like in our warm-up, we found the area of this circle. So the volume of the cylinder then is the area of that circle times the height. So that area, what we said, was 50.3 meters squared, and then we take that times the 10 meters of the height, and we get 503 meters cubed for our volume. So a lot of this section of our notes is just going to be get the volume formula for that figure, substitute in what we know, solve for what we don't. Here we have an example. Says Babrika, the kidney, is a lake in the Rila Mountains in Bulgaria. with the shape of a kidney. Its area is 85,000 meters squared, and the average depth is 28 meters. So you know when you have a lake, it kind of goes like this. It gets deep in certain areas, shallow in areas. So when they tell us that the average depth is 28 meters, it's basically like saying that depth is the same all the way across. It's always going to be 28 meters. So because we know that depth now, we can take the area of the lake and take it times that depth that they gave us, and that'll give us the volume of that lake. So the volume is equal to that 85,000, that's the area, times the depth, the average depth, which is 28 meters. And when we multiply that out, I think if you use the calculators in our classroom, it'll tell you 2.38 E6. What that means is 2.38 times 10 to the 6th power, which means to write this as just a standard number, we move that decimal to the right 6 places. Yeah. So our volume is, and we have 4 zeros afterwards because we moved this 2 and then 4 more places. There's 3, so 2,380,000 meters cubed is our volume of this kidney lake. By the way, if I ever go too fast in this video, that's the lovely thing about a video. You can just pause it and catch up. So, or rewind if you need to revisit something and you didn't quite understand it. That's what it's here for. A cylinder is a special case of a prism with a circular cross-section. The volume of a cylinder where the radius of the circular cross-section is r and the height is h is pi r squared h, because pi r squared gives you the area of the circle, and then the h helps you get the volume. All right, so using this formula for a cylinder, volume equals pi r squared h. Says calculate the volume of the cylinder here with a radius of 2 and a height of 7.5. So it's just substitute in and solve. So pi times 2 squared times our height of 7.5. When you type that all into the calculator, you get 94.2, and this is centimeters cubed. And again, volume is meters cubed. And again, if I go too fast, it's because I've already figured out these into the calculator. So you can always like write this step here with me first, pause the video, type it all in, make sure you know how to type it into a calculator properly, and check that you're doing your 3 sig figs properly. And then play my video again to get the answer to check. So use it the best way that helps you. Example 24 says, find the volume of the triangular prism whose base is an isosceles triangle. So isosceles triangles have 2 sides that are equal. So that means their opposite angles are also equal. Where the equal sides are 12 centimeters and the angle between them is 130 degrees. The height of the prism is 15 centimeters. So they drew this triangle EIJ, which is just this base triangle here. They drew it over here better for you so that you can see where the sides are that we know and the angle that we know. And then the height, they said, is 15. That's this here. So again, to find the volume of a prism, you're finding the area of that base and then taking it times the height. So we need to find the area of this triangle first. So the area of triangle EIJ is going to be equal. Here's a case where we have a side, angle, and side. So we can use that formula where we take 1/2 times those 2 sides that we know, 12 and 12, times the sine of the angle between them, so times sine of 130 degrees. So you would type all of that into your calculator, get your answer. I'm going to keep it a long decimal because this is not going to be our final answer. This is just the area of that triangle. Remember, we're trying to find the volume of this prism. So 55.1552 is the area of that triangle. Again, I'm not going to round that. Oh, hold on. There we go. And then the volume is that area of the triangle times the height. So the 55.1552 times the height, which we were told was 15, and we get 827.328. When we change that to 3 sig figs, we get 827, and this unit is centimeters, so that's centimeters cubed. So again, anytime it's a prism, just find the area of the base and then take it times the height. And don't do your 3 sig figs till you get to your answer, your final answer that they're asking for. All right, let's write down some of these formulas. So the volume of a cylinder is pi r squared h, where r is the radius and h is the height. The volume of a pyramid is 1/3 times the base area times the height. The volume of a cone is 1/3 pi r squared h, where r is the radius of the cone and h is the height. And then volume of a sphere is 4/3 pi r cubed, where r is just the radius from that circle or that sphere, and a sphere is just distance from a central point to every point on the outside of that sphere. So the radius goes in all directions. So let's use these formulas to help us solve some problems here. For part A, it says the volume equals we're trying to find the volume of a pyramid. So when it comes to a pyramid, the volume formula is 1/3 times the base area, times the height. So the base area here is, we have a rectangle. It's 4 centimeters long and 3.5 centimeters wide. So the base area will just be that length times width, so 4 times 3.5. And then our height, they tell us, is 7.4. So when I multiply that all out and take it to 3 sig figs, I get 34.5. And we're talking centimeters, so it's centimeters cubed. For part B, we're trying to find the area of a cone. So the area of the cone is 1/3, or sorry, not area, volume, 1/3 pi r squared h. Now we do know the radius, but we don't know the height. So we need to find the height first. So let's consider that step 1 over here. Find the height of this cone. We see we have a right triangle here where we know 2 of the sides, and we need to find that 3rd side, so we can just use Pythagorean theorem. So remember, your c side is always the hypotenuse, so it'll be h squared plus 3.2 squared equals 11.5 squared. So 3.2 squared gives us 10.24. 11.5 squared gives me 132.25. And then you're solving for that h squared, or solving for h. So we got to take the square root in the end. And again, I'm keeping this a long number because this is not going to be my final answer. This is just getting me the height. So I want to keep that long decimal, don't round it. And now we're going to substitute that into our formula. So we've got the radius, which is 3.2. We've got the height, which is 11.0458. Substitute all that in. And take it to 3 sig figs, and we get 118 centimeters cubed. Alrighty. Example 26 states, a cylindrical can holds 3 tennis balls. Each ball has a diameter of 6. So remember, the diameter goes all the way across the circle. And which is the same diameter as the cylinder. So the ball's diameter is 6, so is the cylinder's. So if I need to know the radius of that cylinder, that would be half of 6, so 3. Sorry, excuse that. I don't have any eraser on here, so R equals 3 if the diameter equals 6. Then it says the cylinder is filled to the top. So these balls filled all the way to the top. So if the diameter is 6, that means the diameter goes this way as well. So there's 6, here's 6, here's 6. So that total height of the cylinder is 3 times 6, giving us 18 for that height. It says calculate the volume of the space inside the cylinder that is not taken up by the tennis balls. So they're wanting all this space in here. So the way we can find that is we can find the how much space the balls take up, and then subtract that from the volume of the whole cylinder. So let's find the volume of 1 tennis ball. So a volume of a sphere is 4/3 pi r cubed. And the radius of these balls is 3, so 3 cubed. And when I type that all into a calculator, I get 113.097. And again, I'm keeping that long decimal so that because I don't want to round until I get to the very end. So that's the volume of 1 tennis ball. And of course, this is centimeters cubed. Now, we've got 3 balls in there, so we just want to find, so to find the volume of 3 tennis balls, you just take the volume of the 1 ball times 3. And we end up with 339.292, because again, I'm not going to round till the very end, centimeters cubed. So that's how much space the balls take up inside the cylinder. So now we want to find out, well, what's the volume of this cylinder? And the volume formula for a cylinder is pi r squared h. So that's pi times 3 squared times the height, which is 18. And again, I'm going to keep the long decimal for now, so 508.938 centimeters cubed. So that's the volume of the cylinder. This is the volume of the 3 balls. So to get this volume of the space that's empty in the can, we just take that volume of the cylinder minus the volume of the 3 balls. And since what we get is going to be our final answer, we do want to go ahead and take this to 3 sig figs. I think we get 169.6, so that would round to 170 centimeters cubed. Now we're going to do a couple of challenging problems. These would be good problems for one of your exams kind of thing. So it's going to kind of work your brain a little bit more. So we've got a diagram that shows a right pyramid with a regular hexagonal base. So what it means by regular is that hexagon base, regular polygons mean they have the side lengths are all the same length and the angles are all the same measure. So keep that in mind as we're working on this. That one word right there is a big clue to help you out. The volume of the pyramid is 84 centimeters cubed and the height is 7 centimeters. O is at the center of the base, and for part A, they want us to calculate the area of the base. So when it comes to area of a cylinder or of a pyramid, the volume formula is 1/3 times the base area times the height. Now they told us what the volume was and we're trying to find the area, and they told us what the height was and we're trying to find the area. So I'm going to substitute in the 84 for the volume. We're trying to find the base area, so I'm just going to keep writing that as base area. And then they told us the height was 7 centimeters. So our goal then is just to get that base area by itself. So first things first, I'm going to multiply the 7 times 1/3, because when we're multiplying 1/3 times the base area times the 7 for the height, we can go ahead and multiply in a different order. We can multiply the 1/3 times the 7, and that just gets us 7/3. So we have 7/3 times that base area. Now to get that base area by itself, we want to get rid of this fraction that's being multiplied times it. So we just multiply by the reciprocal. So we flip that fraction 3 to 3/7, and we multiply both sides by 3/7. And what happens is the 7 cancels out with this 7, the 3 cancels out with this 3, and we're left with just the base area on that side. So the base area is equal to 3/7 of 84 gives us 36. So 36 centimeters squared, because we're talking base area here. Now for part B, it's asking us to calculate the area of triangle AOB. So this triangle here, the thing about this regular hexagon is that it can be divided into 6 triangles that are all congruent to each other. Because it's a regular hexagonal base, that means all the sides are equal, all the angles are equal. So each triangle will have the same area because those triangles are congruent. So 6 triangles make that base. We know the base area is 36. So we can find the area of triangle AOB to be that base area divided by 6, because there's 6 congruent triangles. So that base area that we came up with was 36. We divide it by 6, and we get the area of that triangle is 6 centimeters squared. Because all those triangles, even though because of the way it's drawn, it's tilted, you can't see it, but if we were looking directly at the base from the bottom, it would look like all 6 of those triangles are congruent to each other. So they're all equal to each other because it's a regular hexagonal base. So since we know the base area, just divide it by 6 to get the area of that one triangle. For C, they are asking us to calculate the size of angle AOB. So for triangle AOB, they want us to find this angle here. Okay? Well, we know in a circle, it's 360 degrees, right? So if all of these triangles are equal, then all those angles are equal right here. So all the points of these triangles meeting at O, all those angles are equal. So we can take the whole 360 degrees, divide it by 6, and that'll get us that angle AOB. So the measure of angle AOB is equal to 360 divided by 6, which gets us 60 degrees. But again, all of that for parts B and C, that all is coming from this clue word here, that it's a regular hexagonal base, which means all those side lengths and all those angles, those triangles are all congruent to each other. For part D, it says calculate the length of AB. So if I draw triangle AOB, we just figured out that this angle is 60 degrees, and excuse me, we figured out, what else? We don't know what these side lengths are, but if I figure out these two other angles, because these triangles are congruent, all those distances from that point, center point 0 to these vertices is all the same, because these are congruent triangles. So that means these two side lengths are the same, which means their angles across from them are also equal to each other. That's based on an isosceles triangle. So if I take 180 minus 60, I'm left with 120 degrees. And to split between these two congruent angles, so if I take 120 and divide it by 2, we get that each of those angles are also 60 degrees. So these are equilateral triangles, which means all three sides are equal, all three angles are equal. So each one of those triangles are like that. What they want us to find is the length of AB. So we need to figure out what these lengths are. So I can just call each of these side lengths X, and I can use that area formula of a triangle because we know the area of this triangle is 6. So I can use area formula, which is 1/2 two sides multiplied times each other, along with this multiplying times the sine of an angle in between them, so sine is 60. And I can use that to solve for those side lengths of X. So area, we figured out for area triangle AOB was 6. So that's 1/2 times X gives me X squared times sine of 60. We're working to get those X squareds by themselves. So to get rid of the 2, or the 1/2, I can multiply both sides by 2. We get 12 is equal to X squared sine of 60. From there, to get X squared by itself, divide both sides by sine of 60. And we get 12 divided by sine of 60 gives me, 12 divided by sine of 60 gives me 13.8564. And then to get X by itself, I take the square root. And I get 3.72. So that AB side, along with the AO side and the OB side, all three of those sides are equal, but what they asked for was length of AB, and that's what I used X to represent. So AB equals 3.72 when you take it to 3 sig figs, and this is all in centimeters, and since we're talking about just a side length, it's just centimeters. It's not area, so it's not centimeters squared, it's not volume, so it's not cubed, it's just centimeters. So that one we relied heavily on that it was a regular hexagonal base, and then just used our formulas to substitute in what we knew to help us solve for what we didn't know. All right, one more problem. And again, I had originally made a closure, but I put the wrong closure on the back of your warm-up, so cross out your closure for today. You're not doing a closure today. It was one for the next lesson, so scrap the closure for today. We're just doing the warm-up and homework today. Here, so last question. A solid sculpture consists of a hemisphere of radius 3 centimeters and a right circular cone of slant height L, as shown in the diagram. Show that the volume of the hemisphere is 18 pi centimeters cubed. So we're going to prove that the volume of the hemisphere is 18 pi centimeters cubed. So we're going to pretend like we don't know that it's going to be 18 pi centimeters cubed. So how I go about this is I just figure out what's the volume of the hemisphere, and if I get 18 pi centimeters cubed, that's me proving it. So for part A, we've got volume of a hemisphere is going to be half the volume of a sphere, right? So half the volume of this, what this would be if it was a sphere. So a sphere's formula is 4/3 pi r cubed. We know the radius in this case is 3, so pi 3 cubed. So, and like I said, this 4/3 pi r cubed, that's the formula for a whole sphere. We're doing a hemisphere, so that's going to be half of that. So just go ahead and put all that into a calculator, and you would end up with, I'm going to go ahead and keep pi in my answer, and get 18 pi. Sorry, I had to take a drink. All right, for part B, they want us to find, it says the volume of the hemisphere is 2/3 that of the cone. Find the vertical height of the cone. So they want us to find this height. All right, so they said the volume of the hemisphere, which we just figured out, 18 pi, is 2/3 the volume of the cone. Oh, excuse me. So I'm going to go ahead and figure out what the volume of the cone would be then. And I'm going to have to end up using that to help me find the height. So to find the volume of the cone, since 18 pi is 2/3 of that, to get volume of the cone by itself, we just multiply by the reciprocal of that 2/3. So I'm going to multiply both sides by 3/2. And we get 27 pi equals the volume of the cone. So now that I know the volume of the cone is 27 pi, I can use that volume of a cone formula, which is 1/3 pi r squared h, where we know the radius is 3, so that's pi 3 squared times h. So the volume of the cone, which we just figured out was 27 pi, equal to 1/3 pi 3 squared times h, and now we can find the height. Excuse me. So solve for h in this case. So to get rid of this 1/3, I would multiply both sides by 3. Get a calculator, hold on. So I get 81 pi is equal to pi 3 squared we know is 9, and then times h. So now I'm going to divide both sides by 9 pi to get that h by itself. And we end up with h is 9. And the height, we're talking centimeters, so 9 centimeters. So that was all part B. This got us part A. This is part B. Now we're on to C. I'm going to go up here just so I make sure I have enough room to work. All right, so C, we're trying to find the slant of the height of the cone. So that's this L side. They did a script L, but I write it as a cursive L so you don't confuse it with a 1. We just figured out this height was 9. So here we have a right triangle now, so we can easily identify what that slant length is by doing the Pythagorean theorem. So L squared equals 9 squared plus 3 squared. And then take the square root of both sides. And we get, I'm just going to keep it a square root of 90 just to keep it exact for now, because I don't want to round and mess anything up. But if you took it, as far as answering part C, if you took it to 3/6 figs, I would totally accept that. If you leave it as square root of 90, I will totally accept that as well. D, it says calculate the angle between the slanting side of the cone and the flat face of the hemisphere. So they're wanting this angle here. So we know this side is 3, we know this side is 9. Let's use tangent to find that angle. So tangent inverse, because it's a right triangle here, tangent inverse of that angle, so I'll just give it a variable, is equal to opposite over adjacent, so 9/3. I hit tangent inverse. I'm at tangent of x. We'll take tangent inverse here in a second. So x equals the tangent inverse of that. In which we get 71.6 degrees. And then last but not least, it says the sculpture is made of material that weighs 10.8 grams per centimeters cubed. Calculate the weight of the sculpture given your answer in kilograms. So we want to find the total weight, or sorry, the total volume. And then since it's 10.8 grams per centimeter cubed, once we find that volume of however many centimeters cubed, we just take that times that 10.8 to get the weight. So we want to find the volume of the sculpture. So we know the volume of the hemisphere is 18 pi. We figured that out in part A. And the volume of the cone is 27 pi. We figured that out in part of our part B. And go ahead and get a decimal for this. Go ahead and use pi and type it onto your calculator. And you end up with the volume of the whole sculpture to be 141.372. Again, I'm keeping that decimal alone because that's not what they're asking for in the end. And that's centimeters cubed. So if it's the whole volume is that many centimeters cubed, then and each centimeter cubed weighs 10.8 grams, then the weight is going to be that volume times 10.8. And the weight is in grams per centimeters cubed, so it's going to be in grams. And we end up with 1,526.81 grams. And then to take it to 3 sig figs, because they didn't tell us what to round to, that would be, where can I write this? I'm going to put it up here just so I have some space. 1,530 grams. Yeah, 30 grams. Okay. All right. That's your notes for today. Your homework is to do exercise 2G on page 78 and 2H on pages 80 and 81 in your book. All right. Have a great day, guys.